Okay, here we go. We are now going to take a look at section 1.3. And section 1.3 has a couple of parts to it. The first part deals with formulas, and the second part deals with word problems. So it's models and applications. So let's take a look at the formulas first. Now, to solve an equation, for a variable, when there are other variables in the equation, what you do is you pretend like all the other variables are numbers, and use normal algebra rules. So that's how you solve a formula and rearrange it to get one of the variables by itself. Just simply pretend like all the other variables are numbers, and then treat it like you would a normal algebra equation by trying to get that variable by itself. So let's take a look at a couple of examples here. And I've got 3 examples. I'm going to solve each for the specified variable. And my first formula is going to be y equals mx plus b. And I'm going to solve this for x. Now, interestingly, does anybody know what this is the formula for? Be careful, it's not the, not solve, sorry. Got all excited there. It's not the formula for slope. It is, there again, I got all excited. It is the formula for the slope-intercept form of the equation of a line. Remember, the formula for slope is subtract the y's on the numerator and subtract the x's on the denominator. This is just the slope-intercept form of the equation of a line, which, if you don't know that right now, that's okay. It's important in the next unit, but right now you'll be fine without that. Big thing I want to do right here is I want to be able to get that x completely by itself. So what I do is I pretend like everything else is a number, and I use normal algebra rules. So here's that wall that we talked about when we were solving equations, and I need to get everything away from the x. Order of operations would say if I knew what x was, I would take it and I would first multiply by m, and then I would add b. Adding b is the last thing I said. That's the first thing I'm going to fix. So I'm going to undo the addition of b, and I'm going to subtract b. Remembering that, I'm going to do it on the other side as well to keep things in balance. So now I have a y minus b on this side, and on this side an m times an x. Here again is what I want to get by itself. Oftentimes I'll put a box around what I want to get by itself because it makes it stand out to me, and it helps it to highlight it, and then I can remember I want to get everything away from that. So now I know that I want to undo multiplication by m the way that I undo it is I divide by m. Now folks, you are dividing the entire side by m. Oftentimes, this is what I'll get for an answer. Oops, not an m though. Not an x, I'm sorry. An m. Oftentimes, this is what I'll get for an answer But that's not the case because the whole thing has been divided by m. If you really want to separate it out, then you can write it this way, and this will be fine. But honestly, you don't have to go that far. Don't make your job harder than it is. You're simply taking this side and dividing the side by an m. There's your answer. Either one of these is okay, but most people go with this because it's the easier way to go. And it's perfectly fine. But that's how you take that one and you solve it for x. Now what I'm going to do is another example. Let's take this formula. I'm going to take c equals 5/9, parentheses f minus 32. And I'm going to solve this one for f. Do you happen to know what this one is? This is the formula for converting Fahrenheit to Celsius. Which, if you didn't know that, that's okay. It's not converting Celsius to Fahrenheit because in this particular formula we would plug numbers in for the F, so we're converting Fahrenheit to Celsius. But the important thing here is that I want to be able to solve this for F. This is what I want to get by itself. So once again, here's that wall. I want to get everything away from that F. If I knew what F was, I would plug that number right in here. I would subtract a 32, and then I would multiply it by 5/9. The last thing I said is the first thing that I'm going to fix. So I'm going to fix the multiplication by 5/9. How do I undo that? Well, the way that you undo multiplication by 5/9 is you divide by 5/9. But remember that dividing by a fraction is the same thing as doing what? Yeah, it's the same thing as multiplying by its reciprocal. I'm going to go for the jugular. I'm just going to go ahead and pop it in that way, and I'm going to go ahead and multiply this by 9/5, and I'm going to multiply this out by 9/5. Because remember, when you multiply fractions, what do? Absolutely, you cancel on those diagonals. So I'm going to cancel here, and I'm going to cancel here, and that will give me f minus 32. And on this side, I have a 9/5 c. Now, yet again, this is what I want to get by itself, so now I just got to get rid of that minus 32. To undo that, I'm going to add a 32, and just like before, I'm going to add it to the side. So it's 9/5 c plus that 32, and that will be f. There we go. F is now by itself. All right, one more example of this. And this formula is A equals 1/2 H, B1 plus B2. And I'm going to solve this for B1. What's this the formula for? Well, the fact that it has an A means area. Area of a what? Not a triangle. That would be 1/2 base times height. This has two bases. What figure looks like a triangle but has two bases? Yeah, trapezoid. So this is the area of a trapezoid. That's not that important. Well, it's nice to know, but what's important for us right now is that I want to get that by itself. So here's that wall again. And just like we said before with order of operations, if I knew what this was, I would plug that number in there. What would I do first? I would add the B2, and then I would multiply by H, and then I would multiply by 1/2. The last thing that I said is multiplication by 1/2. That's the first thing I'm going to undo. And like we said before, dividing by 1/2 is the same thing as multiplying by its reciprocal. I'm going for the jugular. I'm going to go ahead and multiply by 2 here and multiply by 2 here. These will cancel. I'm left with H times a B1 plus a B2. And on this side, I'm left with a 2A. I'm getting closer. I want that by itself. Remember, reversing order of operations, the second to last thing we had said was multiplying by this H. So now I'm going to undo that, and I'm going to divide by H. I'm dividing the side by H, so I have a 2A over H equal to a B2. Oh, sorry, equal to a B1 plus a B2. I'm not quite done yet. And like we said before, what I want to get by itself is this. So in order to get it by itself, I have to subtract the B2, keeping in mind, like we said before, I'm subtracting it from the side. So it's the 2a over h minus the b2 away from the side. Because frequently what people will tell me is that the result is going to be a 2a minus b2 over h equal to the b1. But if that's what you're talking about, then you're saying you're going to take the 2a and divide it by h, and you're also going to take the b2 and divide it by h. But you can see right here, that's definitely not what's happening. That b2 is not being divided by an h. So this is not what you want. This is not what you want. What's circled is definitely what you want. And that is how you solve a formula for a particular variable. What we're going to look at now is how to solve word problems. If I can get it to pull up. Okay. Probably going to have to stop this video and pick up another video for the rest of section 1-3. There'll be a second video that will talk about how to solve word problems.